Today we'll start the series RLC circuit, RLC transition circuit. Okay. One minute. It's coming. Okay, see here. We'll start the series RLC circuit. Draw this circuit, series RLC circuit. See here, I'm drawing the circuit on the board. Draw the circuit. Series RLC circuit. So what you had to determine in this? What we had to determine in this? Current equation. Okay, we have to determine the current transition equation. See here, first I will write the loop equation. In the direction of current, you can take plus and minus for resistor, inductor, and capacitor.
Sir, your screen is not visible.
Screen not visible?
Visible, sir. Sir, visible. In your video.
See that? Now here, I want to remove the integral. If integral is there in the equation, we can't apply the differential equation. We can't apply the differential equation. So we have to remove the integral. For removing the integral, apply derivative on both sides. Apply derivative on both sides. That is, derivative of constant is 0. R is constant, di by dt plus L into d square I by dt square plus 1 by C into I. Now I am making the coefficient of d square by dt square 1. Divide the entire equation with L. D square I by dt square plus, I am dividing with L, entire equation. Di by dt plus So I'm making the coefficient of d square I by dt square 1. Divide the entire equation with L. Now this is the second order differential equation. This is second order differential equation. Now see here, I'm taking d by dt is equal to d. That is d square into I plus r by L di. Take I common. This is the second order differential equation. See, I'm taking dy dt is equal to capital D. In place of d square by dt square, it is d square into I plus r by L into di plus 1 by LC into I. Take I common. I want to determine the solution for the current transient equation. I had to determine the equation for the current. First, it is the second order equation. See, d square is there. I'll determine the roots for this equation. In this equation, d square quotient, a is equal to 1, b is equal to r by L, c is equal to 1 by LC. Now determine the roots. So for second order equation, you have to determine the roots. For d square plus r by L into d plus 1 by LC. Now see here, bring this to here. D is equal to minus r by 2L plus or minus. If this 2 coming inside the square root, what it will become? If this 2 is coming inside the square root, it becomes 1 by 4. This can be written as 4 bring inside the square root. 4 and 4 is going to be cancelled. Right on that. Consider minus r by 2l as alpha. Square root of r by 2l whole square minus 1 by LC as beta. Now substitute in that. How many roots we are getting here?
2 roots.
Two roots. One root is, see here, this is one root, this is another root. So what is, now your equation 1 is d square minus or plus r by n into d plus 1 by LC into I is equal to 0. Now substitute these two roots here, d minus, this is one root, first root. Your second root is d minus of alpha minus beta. If you multiply these two, you will get this one. If you multiply these two, you will get this. If you multiply those two, you will get our equation 1. So these are the roots for that equation 1. D minus of alpha plus beta, d minus of alpha minus beta. If you multiply these two, you will get d square plus r by L into d plus 1 by LC. If you substitute alpha and beta. So we are having two roots now. Now I will determine the current equation. Now I will determine the current equation. For determining the current equation, I will consider three cases here. I will consider three cases and I will get three current equations, three different current equations. What are those three cases means? See here. Case 1. First one is overdamped case. Second one, critically damped. Third one, underdamped. In overdamped case, what I will consider is see here r by 2l whole square greater than 1 by LC. I will consider see beta. Inside beta we are having r by 2l whole square minus 1 by LC. In the first case, overdamped case, I will consider r by 2l whole square greater than 1 by LC. Suppose if this is the case, inside the square root we will get positive or negative. Inside the square root we will get positive or negative value.
Positive.
Positive, because r by 2l greater than 1 by LC. That's why I will get positive. Second case, I will consider r by 2l whole square is equal to 1 by LC. Now what is the value of beta?
0.
0, because both are equal. R by 2l whole square is equal to 1 by LC. That is called critically damped case. It is the second case. Now third case is now inside the square root what you will get? Positive, negative value. We will get negative value inside the square root. This is called underdamped case. If you are getting negative value inside the square root, we can take minus common. What is the square root of minus 1?
Under 2.
Square root of minus 1 is j. or I, imaginary number. Square root of -1 is imaginary number.
Yes, sir. I.
Okay. Square root of minus you take common. 1 by LC minus R by 12 whole square. Square root of -1 is imaginary number, I or J. So you'll get complex roots. Under damped case, you'll get complex roots. But in the first two cases, we won't get complex roots because R by 12 greater than 1 by LC, positive value only. So we'll see one by one, case by case. First, we'll see over damped case. For over damped case, what is the value of current transient equation? Similarly, for critically damped case, what is the current transient equation? For under damped case, what is the current transient equation? We'll see one by one. First, I am considering over damped case. Side right down over damped case. Side over damped case. Write down R by 12 whole square greater than 1 by LC. R by 12 whole square greater than 1 by LC. Now see case 1 over damped case. Now I am getting the roots. D is equal to alpha plus R minus beta. Beta is one root is alpha plus beta. Another root is D minus of alpha minus. This is the second root multiplied by current. Okay. Now here, what is the solution for the current now? Write down 1 point. Roots are we have studied the different second order differential equations in first semester. If roots are real and unequal, what is the solution? For second order differential equation? Okay, if roots are real and unequal, what is the solution? For second order differential equation, mathematics we have studied. C1 into e power first root into t plus C2 into e power second root into t. C1 into e power first root into t plus C2 into e power second root into t. That is equal to C1 into e power alpha plus beta into. If you are having minus here, we'll get plus. If you are having plus, we'll get minus. C2 into e power this is the solution for the current. C1 into e power alpha plus beta into t plus C2 into e power alpha minus beta into t. If roots are real and unequal. So this is the equation. Let it be equation 1 for over equation 1. This is for over damped case. Next we'll go for the critically damped case. Any doubt in this equation?
No, sir.
We'll go for critically damaged case. Case 2, critically damaged. Madam, case 2, critically damaged. R by 2L whole square greater than 1 by L. Now this value is 0. Therefore, D is equal to only alpha. Since it is second order equation, we have two roots. Both the roots are alpha only. So, D minus alpha, D minus beta is 0 into I is equal to 0. Now, current solution is roots are now if you are having equal roots, what is the current solution?
Sir, we don't know, sir. Sir, not told this. Second order.
Second order not told in the first semester?
Yes, sir, not told, sir. Not told.
Okay, okay. We'll do one thing. So here if you are having equal roots, then I am writing here C1 plus C2t into e power alpha. Alpha is the root. Here alpha is the root. C1 plus C2 into t. This is the solution if you are having equal roots. If roots are real and equal, only three equations you remember. In the first equation I had told. What I had told in the first equation, I is equal. If you are having roots are real and unequal. If roots are real and unequal, your solution is C1 into e power first root into t plus C2 into e power second root into t. If you are having equal roots, real and equal roots, then solution is C1 plus C2t into e power alpha t. Alpha is the root here. Remember this. Alpha is the root. Okay. This is the solution for the current for critically damped case. This is the solution for the current for critically damped case. Remember this equation. C1 plus C2t is common if roots are real and equal. And e power alpha t. Alpha is the root. In place of alpha, we have to place the root. Whatever the root we are getting. If alpha is 10, you'll get 10 e power 10t. If alpha is 20, you'll get e power 20t. Like that. Then you'll go for the underdamped case. Case 3. I am taking minus common because 1 by LC is get R by 12 is less than 1 by LC. That is 1 by LC minus R by 12. Then this is alpha plus or minus beta. Square root of minus 1. Square root of minus 1 is I am taking it as I because in electrical circuits I is current. That's why instead of I, we'll take it as J. In your entire textbook, in electrical textbook, they will take square root of -1 as j, because the I is the current symbol. That's why they won't take I. We'll take it as j. Okay. Now see the roots here. One root is d minus of, bring this term to side, alpha plus j beta. Another root is d minus of alpha minus j beta into I. So we have determined the current equation. Here roots are imaginary and unequal. Roots are imaginary and unequal. Roots are imaginary and unequal. Madam, roots are imaginary and unequal. Now see how we'll write the solution for imaginary roots. If you are having imaginary roots, here in this alpha is the real part, beta is the
Imaginary part.
imaginary part. Okay. We'll see the solution here now for the current. E power alpha t, e power real value into t, c1 into cos beta t plus c2 into sin beta t. Here this is the real value, this is imaginary value. Alpha is the real value, beta is the imaginary value. This is the solution for the current. If you are having roots are imaginary and unequal. Let it be question 3. So we have determined 3 current equations. In the first case, overdamped case, roots are real and unequal. If roots are real and unequal, then the solution is c1 into e power first root into t plus c2 into e power second root into t. In the second case, roots are real and equal. If roots are real and equal, you will get c1 plus c2t into e power alpha t. E power alpha is the roots. Okay. Next, third one, roots are imaginary and unequal. If you are having imaginary roots, we will write like this: e power first root into t, e power real root into t, e power real value into t, not real root, real value into t, e power alpha t into c1 cos beta t plus c2 sin beta t. Beta is the imaginary value, alpha is the real value, beta is the imaginary value. This is the solution for the current. Only 3 cases you will get in any problem. For second order differential equation, there are 3 cases. One is roots. The first one is roots are real and unequal. Second one, roots are real and equal. Third one is roots are imaginary and unequal. Okay. So if you remember these 3 formulas, we can solve any type of problem for second order differential equation. Now we'll see one problem. So with this we have completed the derivation. In exam we have to derive this. One minute. Take the problem. A series RLC circuit. A series RLC circuit with R is equal to 3000 ohms. A series RLC circuit with R is equal to 3000 ohms. L is equal to 10 Henry. L is equal to
10 Henry and C is equal to 200 microfarad. C is equal to 200 microfarad has a constant voltage, V is equal to 50 volt, has a constant voltage V is equal to 50 volt applied at T is equal to 0. Applied at T is equal to 0. Find the current transient and the maximum value of the current. Find the current transient and the maximum value of the current if the capacitor has no initial charge. So read the problem. They are asking to determine the current transient equation and also the maximum value of the current. First we will determine the current transient equation for this series RLC circuit. Draw the circuit. Draw the circuit. Draw the circuit. We have to determine the current equation. In the direction of current, take plus and minus. V is equal to IR. VL is L into di by dt. VC is 1 by C integral of I dt. VC is 1 by C integral of I dt. So if you want to apply the differential equation, what you have to do?
Apply derivative.
You have to first of all remove the integral in the equation. There should not be integral in the equation. For this, apply derivative on both sides. If you want to remove the integral, if you apply the derivative, automatically integral will be removed. Derivative of constant is 0, 3000 di by dt. That's turned into d square I by dt square plus 10 power minus 6, bring it to numerator. make the coefficient of d square I by dt square 1. Three thousand by 10, 300. What is the value of 10 power 6 by 200 into 10 into I is equal to 0. We are dividing the entire equation with 10. We are dividing the entire equation with 10 because we have to make d square I by dt square coefficient 1.